All right, so in this video, we're going to be taking a look at the difference of parallel and perpendicular, and our focus is going to be specifically on perpendicular slopes. So let's remember, parallel are two lines that are never, ever, ever going to touch, looking like railroad tracks, and perpendicular is two lines that intersect at a 90-degree angle. All right, so we're going to specifically be taking a look at perpendicular. All right, so I have for you another graph, and I am telling you that these two lines are in fact perpendicular. Okay, so these two lines are in fact perpendicular. So again, let's take a look at the equations of these lines. So we have our navy blue line. Our y-intercept is right here at +1. And our slope is up to right 1. So our equation then is y equals 2x plus 1. Okay. Now I just so happened to have it intersect at the y-intercept, but it could have intersected at any of these points. So for perpendicular lines, our y-intercept does not play a necessary role with determining if it is perpendicular. All right, so again, for this purpose, we are dealing with a y-intercept of +1. And notice then my slope is down 1, so that's -1, right 2. Okay, so those are the two equations. Now we can kind of take a look at what is the similarities and what is the differences. So again, our y-intercept doesn't make a role in doing this. We just simply need to focus in on the slopes. So let's take a look. What you should see is a commonality with the numbers 2 and 1. Now, yes, I know this is negative, and that's going to come into play here in just a moment, but you should see that I use the same number. There's not a 3, there's not a 5, there's not any extras with it. It's 2s and 1s. Okay? Notice what we call when the numbers flip-flop from top to bottom is called the reciprocal. So remember that word. So we are dealing with the reciprocal. The reciprocal is the flipping of the numbers. So notice that these numbers are flipped. Notice the top one is positive and the bottom one is negative, and we call that the opposite. So the slopes are opposite reciprocals of each other. One is positive, one is negative, and the numbers are flip-flopped from top and bottom. All right, so we're going to go ahead and write that as our rule for our perpendicular slopes. Okay. All right, these slopes will be opposite reciprocals. Okay, so the slopes will be opposite reciprocals. Okay, so let's take a look at this in action. Which lines are perpendicular? So we need opposite reciprocals, and let's go ahead and write an example of this so we know what it looks like. Another example would be 3/4 would be the opposite reciprocal of 4/3, that is negative. Okay, so here are just some examples that we can take a look at. So which lines are then perpendicular? All right, so let's take a look at this. All right, so we have x equals -2, y equals -4x, y plus 2 equals 1/4 times the quantity of x plus 1, so that's point slope formula. All right, and y equals 1. All right, so something that we also need to write with this, vertical and horizontal lines will always be perpendicular. All right, so go ahead now that we know these points, pause the video and name which sets of lines would in fact be perpendicular to each other. Go ahead and pause the video as needed. All right, so I'm now going to go ahead and give you the answers to this. So A, if I were to graph this, x is -1, so we are dealing with a vertical line. In D, y is 1. So we're dealing with a horizontal line. So if both of these were drawn on the same graph, pair A and D would be perpendicular. Okay. Here we have a slope of -4. Here we have a slope of 1/4. We are opposite, negative and positive, and we are reciprocals of each other. So pair B and C would then be perpendicular.